Welcome back. In our last explainer, we got the basics of rational numbers down, but now we're going to dive into the really cool part, the secret powers and special abilities that make these numbers work. So, I want you to just imagine for a second that numbers aren't just things you see on a worksheet. What if they were actually characters? Each with its own unique identity and a special power that can help you crush your next math test. All right, first up, let's meet two of the most important heroes in the entire number universe. Seriously, these two are the foundation for everything we're about to talk about. Let's meet 0 and 1. Okay, our first hero has a power that's all about addition. It's officially called the additive identity, and it's one of the simplest but most powerful rules in all of math. It just means that when you add this one special number to any other number, absolutely nothing changes. And that hero is, of course, the number 0. A great way to think about 0 is as the invisible man. You can add it to any number you can think of, and that number stays exactly the same. It's almost like 0 was never even there. And what's so amazing is that 0's invisible power works on every kind of number we know. Add it to a positive whole number like 2, it stays 2. Add it to a negative integer like -5, still -5. And yep, even when you add it to a rational number, a fraction like -2/7, it's still just -2/7. That is a truly universal superpower. All right, let's bring in our second hero. This one's power is all about multiplication. We call this the multiplicative identity. And just like 0 does with addition, this number has a really special effect when you multiply with it. Our second hero is the number 1, and we can call it the mirror. So why the mirror? Because any number you multiply by 1 just sees a perfect reflection of itself. It doesn't get bigger, it doesn't get smaller, it doesn't change at all. And just like its partner 0, the number 1's power works for everything. You multiply a whole number like 5 by 1, you get 5 back. Or you can multiply that same rational number from before, -2/7 by 1, and you get -2/7 right back. It's simple, it's powerful, and it's super useful. Okay, now let's meet the next group of characters. I mean, every hero needs an opposite, right? A force that kind of balances them out. Well, in the world of math, we don't really call them villains, we call them inverses. So first up is the additive inverse. This is basically a number's perfect opposite when it comes to adding. When you combine a number with its additive inverse, they perfectly cancel each other out. And that brings you right back to our hero, 0. A really fun way to think about this is as a number's evil twin. So for every positive number, there's a negative version. And when these two twins finally meet, when you add them together, they create this perfect balance that results in 0. So for example, the evil twin of the rational number 2/3 is just -2/3. When you add them up, it's kind of like taking 2/3 of a step forward and then immediately taking 2/3 of a step back. You end up exactly where you started, right at 0. All right, now let's check out the inverse for multiplication. This one's just as important, but it works a little differently. Its goal isn't to get to 0, its goal is to get to our other hero, 1. And it has a special name you've got to know, the reciprocal. To make this one super easy to remember, we're going to get it a nickname, the headstand. And why is that? Because to find the reciprocal of most fractions, you literally just flip it upside down, like it's doing a headstand. So check this out, the headstand of 21/8 is just 8/21. And when a number multiplies by its headstand version, the numerators and denominators all cancel each other out, and the result is always our other hero, the number 1. But listen up, be really careful. This is a classic exam question. There's one number that can't do a headstand, and that's 0. If you tried to flip 0, which you can think of as 0/1, you'd get 1/0. And what's the number 1 rule of fractions? You can never, ever, ever have 0 in the denominator. So 0 has no reciprocal. Remember that. And hey, here's another fun fact for you. The numbers 1 and -1 are so unique, they are their own headstands or reciprocals. I mean, think about it. If you flip 1, you still get 1. If you flip -1, you still get -1. Pretty neat, right? Okay, so we've met the heroes and their opposites. Now let's see how they can team up with other numbers. This brings us to a super useful property called distributivity, but that's a mouthful, so we're going to call it the best friend property. Think of this property like a best friend. Imagine the number A is outside the parentheses, waiting to hang out. Well, it's best friends with the numbers inside, B and C. So it doesn't just multiply the whole group at once. It distributes itself to each friend individually. It's like going into a room and shaking hands with everyone. Okay, but how does this actually help you on an exam? Well, sometimes it's way easier to shake hands with each number one by one instead of adding the group inside the parentheses first. It gives you this awesome shortcut for solving some really tricky-looking problems. Let's take a look at this problem here. We could totally solve it the long way. First, you'd have to find a common denominator for the fractions inside those brackets, then add them together, and then finally do the multiplication. It works for sure, but man, that's a lot of steps. Or we can use our new best friend property. The -3/4 on the outside shakes hands with the 2/3, and then it goes and shakes hands with the -5/6. We do those two simple multiplications first and then add the results. And would you look at that, we get the exact same answer, 1/8. Sometimes this way is so much faster. So, there we have it. We've met the hero identities, their inverse opposites, and the super handy best friend property. We've seen all their powers in action. So, what's your next mission? Well, the big question now is, with all these whole numbers, integers, and all these fractions, where do they all fit? Where do they actually live? In our next explainer, we're going to take all these characters we just met and learn how to find their exact location on the number line. I'll see you then.